We'll now be moving to the next speaker.
Yes.
So it will be Nenad Velisavljevic from LLNL. He will be talking about HPCAT and the current and future direction of that beamline. So please, Nenad, go ahead.
Thank you. And do you see my presentation? And
yes, absolutely.
Okay. So yes, thank you for the introduction. And just as a quick outline, I'll just cover a couple of opening remarks, and then I'll move on to a little bit of what HPCAT is currently, where we're going, and of course, closing remarks. So thank you for the invitation to present. To be honest, it's been overdue, and presenting on my end, at least giving updates on HPCAT. Full disclosure, I'm not a big fan of these online platforms, but that's the mode of operation. So nonetheless, let me proceed and just start off with a little bit with the history of the of HPCAT and how we, where we are, how we got here. So as you guys know, we were established in roughly 2000-ish with core funding from multiple entities, Department of Energy, NNSA, Carnegie Institution, and even I should acknowledge, obviously, UNLV used to be part of HPCAT, and so was University of Hawaii initially. Russ Henry actually did a nice job of kind of giving some of the history earlier on, and I'll acknowledge his help. I think he's been a great champion for the high pressure community on many platforms. And so we operate as a collaborative access team, a CAT, what is known as a CAT here, which means that we split our beam time between partners and general user community. I'll talk a little bit more about that. And then staff was initially managed out of Carnegie Institution of Washington. But in 2018, we went through a significant restructuring change. And I'm speaking to this in a sense so everybody's aware, but also obviously with Jesse Carr's compressed merger, this plays sort of maybe a template or some ideas in terms of how things are managed. On our end, during the transition, all of the HPCAT staff actually became part of the APS. So now all the staff is actually part of the APS X-ray Science Division, and it's the Photon Sciences Director. The only person really that's not part of the APS is myself. I'm hired as a Livermore staff and director. And the way we operate HPCAT is we have a executive council. Obviously, I serve on the council. The group leader, Maduri, sits on the council. We have the national laboratories, the NNSA national laboratories represented each, and also this academic partnerships that I will talk about. Myself as the director, really what I want to point out is the staff is, all of our staff are part of this X-ray Science Division. And as such, I do interact with staff directly in terms of the management. The operations are handled more through APS, so day-to-day operations and maintenance of the beamline is handled through APS. And with that, we do have access to the APS resources such as finances, HR, etc. We also have students. I put them a little bit separately here. One is because students are cool, and it's nice pictures here. So that's one. The other reason is really we have students from various entities. Some are supported through us, through XSD, for example. Some are externally funded. For example, John Copley is coming from this academic stewardship science graduate fellowship. He's a student with Tom Duffy at Princeton, and he's here with us for a couple of years. And we have a couple of other students coming in. The other thing that during the transition that I wanted to maintain is I wanted to maintain the upgrade and some of the other things separate. Of course, the scientific advisory committee and those I will not speak about. But the upgrade project I wanted to keep separate because it is a large scale project. And I didn't think it was fair to lump it in with the funding that we're getting and other staff obligations. Although most of the upgrade project is handled really to our regular staff, we do have some additional staff that's separate. That said, currently HPCAT oversees 4 simultaneously operational beamlines. I think you guys are aware of that, and we are fully funded now by the NNSA. I hate to put money up there. I mean, money flavor is different and costs are different in different institutions, but that's roughly our spending. And we did retain this CAT model. That's important to point out. So as Russ had, provided some history, let me provide some history as well. We have the CAT model was really established or thought of as about 30 years ago It was really supposed to bring similar entities or interests together and come here and be stationed at a light source. And so with the CAT model, I want to point out is that not all CATs are the same, okay? So the CAT, the Collaborative Access Team, really, there are different entities. We have CATs that are funded by government agencies for their purpose. So it's National Science Foundation, for example, funds Jesse Cars. Likewise, National Institute of Health, and on and on and on. There are also CATs funded by consortia, so different folks come with their own money, they come together, common interest, they form CATs. And we have CATs that are funded fully here at APS by industry. So they don't offer any general user proposal time. They mainly focus really on specific projects that they're interested in. And we, myself included here, HPCAT, dynamic compression sector, the two sectors here at HPCAT, they're fully funded by the National Nuclear Security Administration. So we are a little bit different than the other CATs for sure. However, I want to point out is that our beam time allocation, the commitment is still there. As Peter pointed out earlier, we do have a certain amount of beam time at the top dedicated to development projects. 25% remains for the general users, right? So all our techniques that we develop, really, we're not a geoscience sector, just to be blunt, but all our techniques are available and they're certainly applicable to geoscience community. And those 25% is open to all. I don't regulate that. The only thing we say is it's technically feasible or not. If you want to look at the review committee, it's separate of HPCAT. And so if you want to serve on the committee, for example, that's open to you, but we do give 25% to general user community. The other beam time goes to, if I take the rest of the 65% and I split it in half, 50% goes to our tri-lab partners, Los Alamos, Little Sandia. And then we have academic partners. They're also funded to this NNSA entity, right? We have individual PIs. These are some of our core PIs. They come on a regular basis, some more than others. For example, I haven't seen ICARE in over 2 years, but these are the core group. They look at various things, superconductivity, hydrogen, low Z materials, up to high Z materials, PE press, etc. And we also have center PIs, such as Russ and his CDEC center. We have A.B. Hickson and my former colleagues from Los Alamos, actually, Mike Demkovich and Amit Nizar, who are looking at additively manufactured materials. So we have various academic collaborations as well. But as I mentioned earlier, we are an NNSA funded facility. And really the way to look at HPCAT is we fit in this NNSA complex, okay? There are different facilities in NNSA complex, from NIF, that you're probably familiar with, to Sandia Z machine, and all these platforms offer something different. And I believe, and looking at the work that's done across all the synchrotron high pressure facilities, we do offer something unique that's very different from the XFELs, that's different from these facilities. So we provide unique capabilities, and in many ways we are complementary, and in some ways we actually enhance what can be done in these other facilities. And at the end, really for me, the goal is to provide be part of this complex and provide a range of high pressure and high temperature techniques over large time scales. That said, we are part of the larger community. Obviously here at APS, what Jesse Cars and others do does affect us, and vice versa. So I want to make that very clear. We are part of the high pressure community in general. Recently, I and our funding management, we met with Russ Keltz, for example, and we discussed this as well, that it does impact us what you guys do long term. It's vital that we provide as many diverse techniques and capabilities for a large community. And not only that, we are part of the light sources across the US. There are different light sources, as was actually presented today, and certainly across the world. Okay, so from my end, yes, we're NNSA funded, but I am aware of all these different things that the community needs, and these are just some of the examples of the reports. Obviously, there's some newer versions of it, but at the end of the day, I am really funded by NNSA. So this is how this balance works for me. Okay, so really, in summary, we're a science facility where our job is to develop cutting-edge techniques, provide maintenance, and grow user community. So it doesn't matter if you're a GUP, general user proposal, or a core partner, you get the same service. We want to foster next generation. I think that's vital for the community, and also provide some data and techniques that feeds into larger community as well. One example is Guyan Shen working, for example, on this pressure scale recently through ERA. So we do currently, we have 4 beamlines. Before I move into the upgrade, we have 4 beamlines servicing a wide range of X-ray techniques from spectroscopy to diffraction, etc. And so we also have a Paris Edinburgh press. Most of the techniques are dedicated to diamond anvil cell. We also here at the end have a large empty station currently that we want to utilize in the upgrade. As far as the APS, I think that was discussed already. APS is going to go through an upgrade, so there's no surprise there. A lot of the facilities around the world already either have upgraded or are planning an upgrade. At APS, there are a number of things that are happening with the upgrade. There's going to be a number of new featured beamlines, enhanced beamlines, and even this long external beamline. There's additional discussion through NNSA investment about building further long beamlines, but that's only a discussion at this point. And I think you guys are aware that the shutdown will happen in April 2023 at this point. On HPCAT U side, I want to point out a couple of things. Starting from May 2019, I joined in roughly around May, came out here. And one of the things that I realized that over the summer is that we had a lot of science discussion. We never really had any formal plans about the upgrade. And what was more concerning is that our funding sources completely were not aware that we needed any money for the upgrade. And as Peter showed earlier, right, you need to start planning, 5-7 years in advance for some of these things and telling people about the budget and what you need, right? Even though we fight in US year to year about budget, you really need to get on books early so people understand what the costs are. So as soon as I came out here, I'm grateful to Steven Stryfer, the APS director. We went to the Department of Energy headquarters and Divide, and we said, look, we need to have some funding. NNSA was nice enough. They sent me a letter in August and said, give us the cost estimate, full cost estimate and plans within 2 weeks. So I guess the cautionary tale is be a squeaky wheel, but not too squeaky, because sometimes it does backfire. But in any case, we turned around and we provided a cost estimate. What we did is basically we went, wall to wall, basically. Look at all components, look at the science cases, and we estimated that we need about $13 million. It's a high price tag, as I mentioned, to the funding sources, but we're 20 years old. A lot of our components will not be able to take the new X-ray source. So that is the goal that we're shooting for. At this point, what we have so far is this. We did receive, we pushed, we said, look, we need some seed money. We did receive in April 2020, 800K. We got an undulator. We have a canted undulator set up. We got a revolver undulator. It's the best we could get, other than going to like superconductor undulator. But that wouldn't get us much more. We also did receive our first internal, as being part of the APS, we could actually compete for this LDRD internal funding. We did get 3 years at 300K. That was good, and we hired a postdoc. And finally, in April 2021, had to write additional proposals to get, not to go into the gory details of the budget, but we did get $3 million committed this year. It's here with us, and then we'll have to fight for more funding. So we are, we have to spend so we can compete for the money again next February. So we are at least 50% committed. I'll give you one example what we're doing on our IDB side. We are looking at replacing our BDCM, the branching monochromator. We are doing some vibrational studies to see how much of it we have to replace. But we did order a new cryo cooler. That's on the way. We did order new KB mirrors. We have actually in IDB, we have laser heating and a general purpose table. And each one has 2 sets of KB mirrors. So we ordered 4 KB mirrors to service that station. We did do full beam scoping and ray tracing, as Peter pointed out. Look, the source is one thing. But once you hit all the monochromators and KB mirrors, like what actual source do you get in the station? And we are going to get a cleaner beam. They're estimating submicron. We don't need submicron. We'll actually reserve submicron for the other station. We wanted an expandable 1 to 8 micron beam in cases when we laser heat and we get large grains. Let me speed it up a little bit. Sorry. We ordered a new Pilatus 2M detector for the IDB station. We finally upgraded to a new detector. We ordered also 1M detector for our BM station. We still need further investments in the detectors if we want to do all the things we want to do. And the next thing is really, experimental tables. But just to show people that, look, this is a large-scale project. We are treating it as a project in all senses because we have a commitment as a user facility to bring things up as soon as possible, just like everybody else. And so we have this full-scale Gantt charts, the whole 9 yards, because it does require a lot of APS interaction. We're a CAT, but we also cannot do everything on our own. So there's a full-scale project. Okay, so let me move to science drivers in short of time as I can. Really what we're after is looking at materials over wide pressure, temperatures, and strain rates. And this is actually a picture for my colleague Ray Smith of Livermore. As you know, when you compress a material under dynamic conditions, you have a old phase, you get elastic deformation, plastic deformation, new phases. And reality is that's what we also see in a diamond anvil cell, right? We compress a material, we can elastically deform it, plastically deform it, phase transitions happen. Difference really is the time scale, okay? So for us, there's an opportunity now with this upgrade, as Peter has pointed out, to increase the time scale. Why do we want to increase time scale, right? We want to look at things at intermediate strain rates, but we also want time resolution to look at various phase transitions. This is an example of bismuth. As you know, when you heat it, you can get grain growth, you can get melt, you can get resolidification. For us as an NNSA, we're really interested in multi-phase equation of state. We need higher and higher precision and accuracy equations of state. Not only for publications, a lot of our data purely goes through some of these Sesame, LEOS, multi-phase equations of state that are used by national laboratories. And of course, we want to push to higher pressures, better resolution, and imaging. On the spectroscopy side, that beamline that idea is still evolving, I'll be honest. We still have to fight for more money. We have some nice capabilities. As Urshan pointed out earlier, really the timing mode is important, what we can do. So it is evolving. Over the years, we have done measurements that are vital for general purpose, general user community and partners. And really, with this superconductivity measurements, we have a lot of user community that wants to do spectroscopy. Here's some of the recent results from Maduri and Russ Hamley.
1 minute.
1 minute, okay. And so we have a need for spectroscopy, we're yet to be determined. So what's cool is really we have this empty station. We want to utilize the empty station. There are some ideas, we can obviously do radiography and thermography right now. These are some of the test measurements done. But we also want to do a sub-micron type measurements, right? We want to look at the microstructure across phase transitions. This is showing, structural grain changes for each one as a new phase comes in, parent daughter type. And of course, we want to go to 3D in the end and fully map out our samples. And finally, we want to utilize this coherence, yet to be determined, so we can actually look at individual grains as well. The last thing we're looking at right now is we have done and we're doing test measurements for pulse power setup. There is this Veloz machine. I think if you guys are familiar with Z machine, it's the size of a basketball court. It's rather large. There are two different varieties, smaller versions of Z or pulse power machine. We're looking at this Veloz. It's still rather large, 3 by 5 meters. This is in collaboration with our partners from Sandia. We didn't actually insert the pulse power machine yet. This is just doing it at ambient conditions to see if we can actually do it. The goal is before the shutdown to insert this machine into our station and do some actual tests with the pulse power. Yet evolving, all of this stuff is evolving, requires a lot of testing, let me be clear, and it requires a lot more money on our end. Let me just conclude. The APS upgrade is real. I want to show people, we talk about this, it lives in a cloud a lot of times. People think, well, it's not happening. Unfortunately, a lot of people can't drive by due to COVID, but yeah, ground has been broken, new beamline is being built. So it's a full-scale project at this point. And with that, let me thank all of you guys, organizers, obviously, all of my colleagues from around the world, and thank you for sticking around very late. I realized Japan and such is it's very late. And I also want to thank Mark Rivers, Vitali, and all those folks at Jesse Cars for over the years being great collaborators and colleagues. With that, I'll stop. Sorry.
Thank you very much for the talk, Nenad. Yeah. Do we have maybe time for one very, very short question? Vitaly, please.
So if I correctly understand, you plan to develop an IDE station, that velocity machine?
Say again, I'm sorry.
If I correctly understand, you say about IDE stations that you have where you want to put the new Z-type machine.
Yeah. So actually it's a little bit more complicated. We want to do testing. Whether it would stay there is debatable, because there was also this discussion and additional, actually NNSA has sent additional money to do a scoping study to see if we can actually build a long beam line. So, and then also Sandia is also looking at LCLS2 as a potential.
Okay.
For us, really, yeah, I don't know if we have enough flux. We came in, we may have to go to a pink beam. And the one thing is, I don't know if we're mutually compatible, right? We have all these 3D imaging things we want to do. We have small angle X-ray scattering. It's a long beam line that we want to take advantage of. So, it's still yet to be decided if we actually want to host it or not. I think community would certainly benefit, but, cost benefit, right?
Yeah. Okay. Thank you.
All right. So thank you very much. So I thank you, Nenad, once again, and as well as all the speakers that contributed to the session, making it very, very interesting.